All right, so this is an answer from a question a student had from an email. I started typing it out and I realized it's actually probably going to be much easier if I made just a video of this. Although this is probably the 5th take now that I've done of this, so it shows you how difficult this kind of question actually is. The question basically goes like this. So if I have a cart in this situation, like I do here, if I displace it from equilibrium, right, I'm going to gain spring potential energy. So if I move it this way or this way, it's going to gain spring potential energy. But if I move it to the left or down, I'm going to lose gravitational potential energy. But if I move it up and to the right, I'm going to gain gravitational potential energy. So how do I know whether the system has gained energy or whether the system has lost energy? And the answer is it depends. So yeah, let me be a little more particular here. I'm going to simplify things and say that the spring right now is at equilibrium. If it's not at equilibrium, you know, things get a little more complicated. Let's say, for example, it's not at equilibrium. Right here is at equilibrium. So if I let go, this thing at first has gravitational potential energy, and then as it goes down, it's going to lose spring potential energy and gravitational potential energy as it goes down, right? But I'm going to simplify things because really what it boils down to, especially with the gravitational potential energy, with spring potential energy, wherever the equilibrium position is, the displacement from equilibrium, that's what gives it the spring potential energy, and that's what gives spring potential energy its 1/2 kx squared. Whatever your displacement, whether it's positive displacement or negative displacement, that thing's being squared, and that's always going to gain potential energy for you. So whether I move the spring this way or this way, assuming this is the equilibrium position, that's going to gain spring potential energy for that thing. And you really want to be just really particular and really specific with your bookkeeping here. It's often what a lot of energy calculations are, is bookkeeping. When am I gaining energy? When am I losing energy? And is that energy conserved, or does it stay the same, or does it change? So let's say the cart right now is at equilibrium for the spring. And let's say that I call this my 0 mark. So right now, I've got gravitational potential energy equal to 0. And I've also got spring potential energy is equal to 0, right? The cart is at equilibrium, and it's at my 0 mark that I arbitrarily called 0. I didn't have to call that 0. That's just what I called 0. And this is one of the reasons why expressing a 0 mark or expressing potential energy at any particular point, unless we all agree on the 0 mark, is kind of arbitrary. It's how the potential energy changes that matters. Okay, so now I will physically grab the cart and move it this way. I've taken the cart and displaced it from equilibrium. It's not completely at the bottom of the ramp, but now it's at this new spot. Let's say now it's got a gravitational potential energy of -2 joules. And then I measure the spring potential energy, right? I've displaced it from equilibrium, so it's actually gained potential energy, and the potential energy is now 6 joules. So it's got 6 joules of spring potential energy. What's the total energy of the system? The total energy of the system now is equal to +4 joules. And that's because I did work. I displaced the cart with a force this way at a displacement this way, and that's positive work that I did that put positive energy into the system. But let's say that so yeah, there you go. I put positive energy into the system, 4 joules. But let's now say I start now with, I'm going to make my 0 mark down here, right? I'm going to make my 0 mark down here. So here's my 0 mark, and now I've got now I've got, let's say 3 joules. I got 3 joules of gravitational potential energy that I measure, because now my cart is above the equilibrium position. Spring potential energy is still going to be 0. It's still at its equilibrium position. I haven't changed that yet. But again, I take the cart and I displace it to this final point right here. Right? Well, still, I'm going to gain 6 joules of potential energy, of spring potential energy. That's still going to be my final potential energy there. But now my gravitational potential energy is going to be 1 joule of potential energy. Right? So the total energy at the beginning was 3 joules. So let's see if I can. My initial energy plus any work I do is equal to my final energy. So my initial energy is 3 joules plus the work I do is equal to my final energy, which is 7 joules. Right? So what's the work I do? It's equal to 4 joules, because I put 4 joules of potential energy into the system. So hopefully you can see here, at least what I've shown you here, is that wherever you make your 0 mark isn't really the point. What you want to worry about is how the change in potential energy matters, and often you want to be strategic in how you already just by doing this I've overcomplicated things. There's often a point to make your 0 mark that would make all your measurements much easier. You don't have to kind of worry too much about this kind of stuff. And you can, so I'm going to throw away now all these numbers and everything like that and talk about kind of the other way, because the other thing that I can do here that you can probably imagine, which is, again, let's say it's at equilibrium. So the cart is at equilibrium right now, and it doesn't matter. I can make my 0 mark at the bottom. I can make my 0 mark here. I can make my 0 mark anywhere I want. But you can see if I pull this way, right, I've done work, and I've not only gained gravitational potential energy, but also if I displace it up here to this point, I've also displaced it, so I've smushed the spring. I've displaced it in the opposite direction. I've also gained in spring potential energy. So by doing work here, I could do the same amount of work, and I would have gained both gravitational potential energy and spring potential energy at the same time. I hope that didn't confuse you too much. I hope it actually gave you a bit of a clarification. Please continue to email me if I've screwed anything up or made things worse. And I hope that helped. All right, take care. Bye.